These are great trucks, aren't they? Part of what makes them great is their ability to give your customers exactly what they need from their truck, specifically four-wheel drive performance. Now, while Ford offers four-wheel drive systems in Aerostar, Explorer, Ranger, Expedition, and F-Series, your customers' needs will determine which system is right for them. If you make the match, the right system for the customer, you've probably got a customer for life. Finding that perfect match can be a little daunting. I mean, Ford offers a variety of four-wheel drive systems, some of which seem quite similar. In the next few minutes, we're going to take a close look at each of these systems. When this program is over, you're actually going to know what they do and how they differ. Armed with this knowledge, you can make that perfect match. Okay, let's get started. The drive systems we'll talk about today are standard four-wheel drive, including touch drive and select drive, electronic four-wheel drive, or E4WD, Control-Trac four-wheel drive, and all-wheel drive. We're going to explore the features and functions of each system and detail the differences between seemingly similar systems. Finally, we'll give you some idea of where the competitive systems fit in. You're in the trenches facing different truck customers every day. A customer considering an F-150 probably won't be happy with an Explorer, but you never know. It's up to you to determine what type of customer you're dealing with and how best to meet their needs. Typically, Ford truck customers fall into three categories: personal use buyers, recreational use buyers, and commercial use buyers. Personal use buyers are interested in the image of their truck. They like its go-anywhere ability, but they're buying the truck for everyday use, not necessarily as a work truck. These customers will most likely be attracted to Highline Ranger models, Explorer, and Aerostar. The new Expedition or an F-Series XLT model might also prove appealing to the personal use buyer. Once again, listen to what they need and direct them accordingly. The recreational use buyer usually needs a truck to tow a boat or trailer. Towing ability is crucial to their purchase decision, and they're also looking for expanded passenger volume. They'll be most interested in Super Cab F-Series, Expedition, and Explorer. And finally, you'll meet commercial use buyers. These folks need a work truck, and they'll be shopping the F-Series and Ranger. Despite their differing needs, all of these customers want the same feature on their truck, and that's its four-wheel drive capability. Your customers will look to you for an explanation of Ford's various four-wheel drive systems. So here we go. Oh, before I forget, we've got an expert on hand to help us out with this subject. His name is Dan Showalter, Chief Four-Wheel Drive Engineer from Borg Warner Automotive. They design and build Ford's four-wheel drive systems. Dan will be explaining the various systems, and I'll be jumping in every once in a while with some useful information. First, let's get some basic information out of the way. Take a look at this chart. This shows a vehicle's power transfer from the engine all the way to the drive wheels. For instance, a rear-wheel drive vehicle receives energy into the transmission. It moves into the drive shaft, through the differential, and onto the drive wheels. A front-wheel drive vehicle receives its energy into a transaxle, through an output shaft, through the differential, and onto the front drive wheels. If the vehicle has a manual transmission, the clutch will transfer power from the engine to the transmission. If the vehicle has an automatic, it uses a torque converter to do the same job. There are a couple of items here worth defining, and one of those is torque converter. Now, in a manual transmission, the clutch will disengage the transmission from the engine in order to select the proper gear ratio for the desired speed, first, second, third, and so on. In an automatic transmission, you've got a torque converter. This device transforms mechanical power or torque from the engine into hydrokinetic or fluid power to the transmission. Here's something that flies in the face of conventional wisdom. A torque converter usually makes the automatic transmission a better choice for heavy towing or hauling. because its energy transfer is more efficient than that of a manual clutch system. Also, the torque converter eliminates having to slip a manual clutch excessively at startups. Keep this in mind for your recreational and commercial use buyers who plan to tow or haul with their truck. The transfer case. You'll hear that term throughout this program. A transfer case is used on four-wheel drive models to provide engine torque to the second set of wheels. For example, the transfer case is mounted to the transmission and divides the engine torque between the front and rear axles when four-wheel drive is selected. There are two types of transfer cases. A full-time transfer case operates in four-wheel drive at all times, eliminating the need for shifting in and out of two-wheel drive. A part-time transfer case allows the driver to shift in and out of four-wheel drive as required. All Ford part-time transfer cases are two-speed, specifically 4-high and 4-low. The main benefit over a full-time transfer case is improved fuel economy when it's operated in two-wheel drive. Okay, let's take a look at the first system, the standard four-wheel drive system. If you've got a customer buying a truck with a manual shift, then they'll be asking plenty of questions about this system. Let's hear what Dan Showalter has to say about it.
The standard system is a part-time four-wheel drive system. The basic transfer case is a manual shift transfer case with the shift lever located on the tunnel between the driver and passenger seat. The shift lever can be moved between the two-wheel drive position, which is used for normal types of highway driving, four-wheel drive, which is for those conditions where additional traction is needed, such as off-road, and normal vehicle operating speeds are being used. And then four-low position is when you shift into it, you get a 2.5 to 1 reduction, which provides additional pulling power and reduced vehicle speed for those situations such as off-road driving over very rough terrain where you need to keep the vehicle speed down, or pulling off a boat ramp. Now, when you shift to four-wheel high, there's a light that illuminates on the instrument panel that indicates that you are in four-wheel high position. When you complete the shift to four-low, there's a light that indicates that you're also in four-low. The vehicles are equipped with either manual hubs or automatic locking hubs. The automatic locking hubs don't require any action from the driver other than shifting the transfer case. The shift into low range has to be done with the vehicle stopped. The manual locking hubs, you do have to get out of the vehicle and lock the hubs. Those could be locked ahead of time, or when you need it, you can actually just get out and lock the hubs at that time. With the touch drive, there's a push button switch where there's two buttons. To select 4-high, you push the 4-high button. That can be done at any vehicle speed up to 55 miles an hour. That will automatically engage the front hubs when it brings the front prop shaft up to speed. As you're driving down the road, the front prop shaft won't be turning while you're in two-wheel drive. But when you push the button, there's an electric clutch that will speed up the front prop shaft, cause the hubs to engage, and you'll be driving in four-wheel drive. For four-low, you have to have the vehicle stopped. The transmission has to be shifted to neutral, and your foot has to be placed on the brake for the shift to take place. If you don't have those conditions met, then it will not accept the shift when you push the button. The select drive is a rotary knob, so that you move it to the position that you want to be driving in. You turn the knob from two-wheel drive to 4-high, and the shift will take place the same way as it does with the touch drive by pushing the button. However, if you shift to 4-low when the conditions aren't met, it's much the same as pushing the button at the wrong time. The shift will not be accepted until those conditions are met. You've got to bring the vehicle to a stop, put your foot on the brake, and shift the transmission to neutral.
So there you have it. The standard four-wheel drive system can be purchased with a manual shift or with the automatic shifting options of either the touch drive or select drive electric shift, depending upon the model purchased. By the way, manual locking hubs are available on manual shift systems on Ford Ranger and F-Series. That's a clear advantage over Ford competitors. Before we move on to our next four-wheel drive system, I need to hit you with a couple of other definitions. Believe me, knowing these before we move on will help a lot. Axles. Rear-wheel drive axles on Ford trucks come in two general types. The first is the semi-floating axle. It supports the weight of the vehicle with the axle shaft as well as the axle housing through the use of bearings mounted directly to the axle shaft. It's lighter weight than the full floating axle, and it's generally used for trucks with a gross vehicle weight ratio, or GVWR, under 8,500 pounds. For trucks with a GVWR over 8,500 pounds, there's the full floating axle. It uses the axle housing to support the weight of the vehicle. The axle shafts float within the housing and only transmit torque to the wheels. This axle is more appropriate for heavy-duty applications. In addition, the vehicle with full floating axles can be towed even with a broken axle shaft because the wheels will still rotate. Now, if you're talking about axles, then you've got to talk about differentials too. Ford rear-wheel drive trucks use a differential in the rear axle to transmit power from the drive shaft to the rear wheels. It uses a set of gears to transfer the drive shaft's torque to the axle shafts, which drive the wheels. The differential also aids in cornering. It actually allows the wheels to turn at different speeds when traveling around corners to avoid that hopping effect. And one final definition before we move on. Limited slip rear axle, or limited slip differential. This delivers torque in proportion to which axle shaft is spinning slowest. In other words, it sends more power to the wheels with the most traction. Without a limited slip rear differential, a typical differential would send torque to the axle spinning fastest. This differential reasons that a faster spinning axle needs more power, and so it sends it there. If one tire has very little traction, maybe it's on ice, it can only use a small amount of power before it spins. The opposite tire, even if it's on good pavement, would only get this same small amount of power. This may not be able to move the vehicle. In contrast, the limited slip rear axle can transfer torque to the tire with more traction through the use of clutch plates and springs contained within the differential. In other words, it reasons, in a mechanical way of course, that the spinning axle must be slipping. So torque should be sent to the axle spinning the slowest because it probably has more traction. Clearly, a limited slip rear differential comes in handy when traveling in slippery or adverse weather conditions. Okay, that's enough with the definitions. Let's move on to the next system. The electronic four-wheel drive system is exclusive to Aerostar. It's called the E4-wheel drive system. This system offers full-time four-wheel drive, requiring no driver input. Aerostar's E4-wheel drive features a center differential to equalize speed differences between the front and rear wheels. This avoids tire scrubbing or torque windup when operating on dry pavement. Under normal driving conditions, the transfer case divides engine torque 1/3 to the front wheels and 2/3 to the rear wheels. This system uses special speed sensors that continuously check for wheel slippage. It's a microprocessor-controlled system that automatically adjusts the flow of power to the wheels for optimum traction and fuel economy. Now, when a wheel does slip, a computer signals the electromagnetic clutch to begin the anti-slip procedure. That procedure operates as follows. For a few seconds, the slipping wheel's drive shaft is immediately locked to the other drive shaft to prevent the loss of available engine power while diverting torque to the wheels with the most traction. This is an automatic procedure from the driver's point of view. It feels like a shift from an automatic transmission. One more point about the system, the Aerostar driver will see the E4-wheel drive indicator light illuminate briefly during engine startup. If this light illuminates at any other time or flashes, the system may be malfunctioning and the vehicle should be immediately serviced. Now, we move on to one of the most popular four-wheel drive systems on the road today, Control-Trac. It's exclusive to the Ford Explorer and the new 1997 Ford Expedition. Its key feature is its ability to provide power to all four wheels of the vehicle whenever the traction from the rear wheels is insufficient. Control-Trac offers three settings. First, there's two-wheel drive for normal on-road driving. In this mode, 100% of engine torque is supplied to only the rear axle. Next is four-wheel drive auto. This is used for many road conditions and provides an initial 4% engine torque to the front wheels, offering more when conditions dictate. It's a set-and-forget system that automatically responds to road conditions when electronic sensors detect wheel slippage. There's four-wheel drive low for off-roading or when on a slippery boat ramp. Four-wheel drive low provides continuous four-wheel drive with a 2.5 to 1 gear reduction ratio for added pulling power. In 4x4 low, the transfer case locks the front and rear portions of the drivetrain to tackle the most extreme conditions. The Explorer driver can switch into any setting using a 3-position rotary switch on the instrument panel. The vehicle must be stopped when engaging 4 low. At this point, let's bring back Dan Showalter for more about the Control-Trac system.
The Control-Trac system is new in 1996. It's a computer-controlled transfer case where the torque that's delivered to the front is actually done by a computer. Now, the driver has a similar switch as what they would have in a select drive. There would be 3 positions that the driver can choose. The driver can choose two-wheel drive. In the position of two-wheel drive, all of the torque is going to the rear axle of the vehicle, and the front axle is disengaged by a center axle disconnect system. Now, this center axle disconnect system is the same type of mechanism as in the 1997 F-150. This is a vacuum-actuated clutch, so it disengages one of the axle half shafts, so the front portion of the powertrain doesn't rotate in two-wheel drive. Now, when the driver selects four-wheel drive, the first thing that happens, or selects auto mode, the first thing that happens is the clutch inside of the transfer case is energized. When that clutch is energized, the front shaft of the transfer case comes up to the same speed as the rear. When that speed's attained, then this disconnect system engages on the front so that you have a connection between the engine, through the transmission, through the transfer case, into the front axle. Once this connection is made, we're monitoring the speeds of the front and rear prop shaft by speed sensors that are located in the transfer case. When wheel slip is detected, so that when the wheel just begins to slip faster than the front wheels on the rear wheels, the clutch is increased in its level of torque so that more torque gets sent to the front. When more torque is not needed, the clutch operates at a very low level. At this low level of torque, there's very little added wear to the powertrain so that someone could drive in this auto mode all the time. There's no binding in parking lots like you'd find with a part-time system where the front and rear shafts are actually locked together. This allows relative rotation between the two. As you're driving down the road in the auto mode, even though you're in four-wheel drive, there isn't a lot of noise and a lot of vibration because the torque level is very low until you actually see wheels slip. The third position that the driver can select is low range. Now, to select low range, much like with the Select-Trac, you have to slow down, stop the vehicle, put your foot on the brake, put it in neutral, then select low range. When you select low range, a motor actually shifts the transfer case into a low range position. Now, when you're in low range, the transfer case clutch goes all the way up to system voltage so that it operates like a locked up system for off-road operation.
One final reminder about the Control-Trac system. The 4x4 indicator will illuminate when the driver chooses auto four-wheel drive. If the driver chooses four-wheel drive low, the 4x4 low indicator light will illuminate. Before we leave our discussion of Explorer's Control-Trac system, there's one other Explorer feature that will be of interest to our customers who intend to tow Explorer. It's Explorer's neutral tow feature, and Dan Showalter is back with a brief explanation.
The neutral tow feature is something that would have to be enabled by the dealer. Initially, as the vehicle is delivered, the neutral tow is not enabled. But once it's enabled, it can be shifted into a transfer case neutral. Now that allows the vehicle to be flat towed with all four wheels down on the pavement with the transfer case actually in neutral, so it's not turning the transmission. This reduces wear and drag on components, and it doesn't damage the transmission. The vehicle can be towed indefinitely that way. Be sure to tell your customers that to enable the neutral tow feature, they'll need to follow these procedures. First, they'll need to release the parking brake. Then they should turn the ignition switch to the off position in order to unlock the steering column. They can then place the automatic transmission in neutral. Depress and hold the brake pedal down for 5 seconds. When the neutral tow feature is engaged, they'll hear an audible chime. It is now in transfer case neutral. Leave everything just as it sits and get out of the vehicle. Now the vehicle can be towed. Remember that this procedure applies to all V6 Explorers having the neutral tow feature. Also remind your customers that the vehicle can roll freely when the neutral tow feature is engaged. This procedure should not be done without the vehicle being secured to the towing vehicle.
The final system we'll examine today is all-wheel drive, available on the Ford Explorer with a V8 engine. This one's so simple, I think I'll try to explain it without Dan's help. All-wheel drive is a fully automatic, full-time four-wheel drive system. It requires no driver input because the vehicle automatically responds to changing road conditions. This system uses a viscous coupling clutch plate assembly and a center differential to send power to the wheels with the most traction. To be a bit more specific, under normal driving conditions, the all-wheel drive system has a 35-65 torque split, 35% to the front and 65% to the rear. When wheel slippage occurs, the torque split varies, sending power where it's needed the most, specifically to the wheel with the most traction. All-wheel drive can send almost 100% torque to either set of axles as needed. Now, if your customers are like me, the description raises a pretty obvious question. All-wheel drive sounds just like E4-wheel drive and Control-Trac's auto four-wheel drive. So how are they different?
Each of the systems have their own unique differences to them. The Control-Trac system offers a position of two-wheel drive. The other two systems do not offer two-wheel drive as a position. So you can select two-wheel drive and it disengages the front axle. The two other systems both have an always live front axle. The Control-Trac system is the only one of the systems that offers a transfer case neutral for flat towing. The differentiated units, both of them have a 65% torque to the rear and 35% of the torque to the front inside of the transfer case. Now, all three systems you can drive in the four-wheel drive position without any driver interaction, and you can drive indefinitely in that position on all road conditions. Both the all-wheel drive system, which is found in the V8 Explorer, and the E4WD system found in the Aerostar use differentials inside the transfer case that give the natural 35-65% torque split between the front and rear. The electronic system in the Aerostar and the Control-Trac system both rely on electronics and a magnetic clutch to bias the torque front to rear. The all-wheel drive system, however, uses a viscous clutch to bias torque when there is wheel slip between front and rear. So each of the systems have some things in common with the other systems, but they all have their own unique things that go along with it.
Okay, I get it. E4-wheel drive and auto four-wheel drive both use computer-controlled sensors to detect slippage. while all-wheel drive uses the viscous coupling and responds solely to drive shaft speed changes rather than sensors. I know that E4-wheel drive and Control-Trac have a couple more differences worth noting. E4-wheel drive relies on a center differential, along with the electromagnetic clutch plate, to vary torque depending on slippage. It also only has a single-speed transfer case. Control-Trac does not use a center differential, and this allows room for a two-speed transfer case. With Control-Trac, the driver controls how much torque is needed by choosing one of the Control-Trac settings: two-wheel drive, four-wheel drive, auto, or four-wheel drive low. Truck customers are tough customers. They shop around, and they know what the competition has to offer. You should know this too. With regard to four-wheel drive systems, there's one general fact. Some competitive systems are virtually identical to Ford systems. Only the names are different. Let's take a look at what I mean. Jeep Grand Cherokee Limited's Quadra-Trac system is similar to the all-wheel drive system found on the '97 Ford Explorer with the 5.0-liter V8 engine. GM's Insta-Trac system with electronic shift transfer case found on the GMC Jimmy, Chevrolet Blazer, and Tahoe is comparable to Ford's Touch Drive and Select Drive four-wheel drive systems. Oldsmobile Bravada's Smart-Trac all-wheel drive system is comparable to Explorer's all-wheel drive system. Finally, Dodge offers Ram-Trac, and it's similar to Ford's standard manual shift part-time 4x4 system. Before I wrap things up, I'd like to bring Dan Showalter back to address the testing of these systems. I understand they undergo rigorous scrutiny. Dan, can you tell us a bit more?
Each of the transfer cases undergoes a very rigorous test schedule. That includes cycle tests, where we apply load and release load at cycling intervals to fatigue parts. Dynamometer testing, where we put the transfer cases behind an engine and we drive them until they fail and determine at what point they will fail. Sand wash testing, where the vehicle is put into very deep, soft sand out in Arizona. And we also do off-road testing in Borrego Springs, which is a public accessed area of deep sand where the vehicles are used very abusively, much worse than anyone will drive their own vehicle.
Those are Ford's four-wheel drive systems. As you can see, each is unique, offering something different for your customers. Making the perfect match requires you to listen to their needs and determine which truck and which system will best meet those needs. Once you make that match, be sure to conduct a thorough delivery to fully explain the operation of the four-wheel drive system to your customer. If possible, you should try to take the customer off-road to clearly demonstrate how to use the system. Real-world experience has the greatest impact. Also, stress to your customers the importance of studying their owner's guide, especially as it pertains to four-wheel drive operation. They'll need to know how the system functions, and the owner's guide will give them the step-by-step explanation they'll need. Well, we hope you've learned a little something that you can put to work for you. Good luck matchmaking.